So, well, here they say to us, the following wave pattern is produced by a transverse wave that takes 4 seconds to complete one vibration. In other words, the period of this wave is 4 seconds. That's what they're trying to tell you. Now, if you look at this wave, you're actually given nothing except the period. Then the first question says, define the term transverse wave. And the next one says, please determine the frequency. So it's very easy to find the frequency because we know the period. Okay. Then the next one says, if the speed of the wave is 0.05 meters per second, then calculate the value of x and find it in millimeters. Now the question is, what is the distance x? Well, if we give it a good look, from this point all the way to there, it's one wave and then you have that, right? So this distance is actually, we can say it's the wavelength of 1.5 waves. Why do we say it's the wavelength of 1.5 waves? Okay, I'm going to show it to you on the whiteboard. So let's begin by finding the frequency. Well, the frequency is just going to be equal to 1 over period. And since the period is 4 seconds, then the frequency becomes 0.25 hertz. That's fine. The next question is asking us to find the distance x, and we must find it in millimeters, okay? Now, this is what I wanted to demonstrate. So here we actually have something like this one. And then you have something like this. This is what you are having. And the distance x that we need to find is actually the distance from here all the way to there. Okay? That's fine. Now, this is what I want you to realize. If you look at this portion, this is one complete wave, this portion. Now, if you take the remaining 2 portions and you add them up, it's going to give you a pulse. So it's going to give you something that is like that. So what can we say? We can say, well, this is a pulse, which is half of a wave. So it's like here they're saying to you, find the wavelength of 1.5 waves. And the wavelength of 1.5 waves will be the distance x. So that's how you break it down, okay? But now we need to begin by finding the wavelength. In other words, the wavelength of one wave, and then we can get to 1.5 waves by using the wave speed formula, saying speed is frequency times the wavelength. And the speed is given to us as 0.05. The frequency, we just found it. Now we are looking for the wavelength. Then we divide both sides, of course, by 0.25. And we find that the wavelength is going to be 0.2 meters. But then we need to convert it to millimeters, all right? Well, we convert it to millimeters by multiplying With what? With 1,000. Why do we multiply by 1,000? Well, it's because according to King Henry, who died a very miserable death, which is called measles or whatever it is you call it, from meter all the way to millimeter, the distance is 1,000. And we want to move from something that is big to something that is small. So we multiply. That's fine. So if you say 0.2 times 1,000, you get 200 millimeters. Now, what you found here is the wavelength of one wave. In other words, it's the distance from here to there. All right. So now it's time for us to find the distance from here to there and then add those up. Or we can just say the distance of the total number of waves, which is 1.5. So now you can come and say one wave is going to have a wavelength of 200 millimeters. So now you want to know what will be the wavelength of 1.5 waves? Well, you say this one divided by that, multiplied by that. And so you simply get 300 millimeters. And now you can conclude and say the value of x will simply be 300 millimeters. And if you said this, they're going to be so happy in the exam that they give you all the marks. Over and out.